Welcome to Ask and Learn.
In this problem, we have to analyze the physical structure of sodium chloride. And this is really helpful because now we get to see the interactions between anions and cations and how these would be spatially arranged in space, how we would see these molecules really if they were to be built. So let's first draw a plane of sodium chloride, and this is what it would look like. It is a cubic structure, and these green balls represent chloride, or the chlorine anions, and the smaller purple balls represent sodium, and these are sodium cations. So this is what our structure would look like if we would to make a sodium chloride molecule and basically cut a slice of it. This is what it would look like. So now we have to analyze the different chemical properties of it. Remember that the purple balls are sodium cations. Sodium has the electron configuration of neon 3s1. So that means it has a s electron in the 3 orbital. So we would see that the sodium cations occupy the 2, 4, 6, and 8 balls of our structure. And we can analyze this doing a similar process for chlorine. Our green balls are the chlorine anions. Remember, the chlorines are negatively charged, and its electron configuration is neon 3s2, 3p5. So now chlorine has electrons occupying the 3s and the 3p orbital. So we would see that the balls that are chlorine are 1, 3, 5, 7, and 9. So now we have to understand the interactions around ion 5. So let's scroll back up and see ion 5. This is ion 5, our central ion. So what we'd see is that ion 5 is surrounded by 4 anions. So ion 5 would experience 4 electrostatic interactions. Now, if you don't know what electrostatic means, all this means is that the interactions between the electrons of the central ion, ion 5, and the anion surrounding it. So then ion 5 would also experience electron repulsion. So what this is saying is when electrons get closer and closer together, they have the same charge, so they're going to repel one another. And that's what ion 5 would be experiencing. But ion 5 is going to experience more electrostatic interactions than repulsion, because remember, we need at least 2 electrons or 2 molecules with electrons to repel one another. And finally, we have to discuss the lattice energy. Now, we talk about the lattice energy because we're talking about a physical structure of sodium chloride. We call those a lattice. So the lattice energy is inversely proportional to bond length. So what that means is that if bond length increases, lattice energy would decrease. So what we see in our structure is that the energy occupied by our bonds is decreasing in our structure, so our lattice energy is going to increase of sodium chloride. So I hope that this problem helped you understand, or maybe even introduced you to a concept of solid state chemistry and how we can analyze the ions in a solid structure by focusing on electrostatic interactions and electron repulsion.